So let's try to find out the general term of a given arithmetic progression. So let's say we have a sequence which is given by the first term a1, the second term is a2, the third term is a3, the fourth term is a4, and this goes on. And let's say that the nth term is given by an. So that we will try to find out this nth term, which is also going to be the general term of the given sequence. So we'll consider that this sequence be in AP. So this is an AP. This would mean that this is going to have a common difference. So the common difference is going to be, let's say we consider the common difference to be equals to D. That would simply mean that when we consider our first term, that's simply A1, our second term A2, which can be obtained by adding the first term, which is the previous term, to the common difference. Then we can find out the third term. So our third term will be, we'll consider the previous term, which is the second term A2, and to it we are going to add the common difference, that is D. And we have already obtained that A2 is given by A1 plus D. So that means this will be equals to A1 plus 2D. Similarly, we can find out the fourth term. So this will be equals to A3 plus D, or we can say this will be equals to A1 plus 3D. Now here we can see a pattern. So what we can do, we can rewrite each of them. So if we start with the fourth term, we can rewrite it as A1 plus, so A1 is the first term added to, so 3 can be also represented as 4 minus 1 times D. If we consider our third term, this can be represented as A1 plus, so instead of 2, we can rewrite it as 3 minus 1 times the common difference. And the second term, this can be represented as A1, the first term, plus we have D, which is 2 minus 1 times D. And our first term can be represented as A1 plus, we have 1 minus 1, which is 0 times D. Here we do not have any common difference. So here we can see a trend that is being followed. So if we continue writing in this particular fashion, then we can say that the nth term of the sequence can be also given by the first term plus, now we can look. So here we had fourth, this was the fourth term, so this was given here as the fourth term. So in case of the third term, we have a 3 present here. In case of the second term, we have a 2 present here. And for the first term, we have a 1 present here. So that means for the nth term, this will be n minus 1 times D. So this is going to be the nth term of our given arithmetic progression. Right. So this is the general formula. So we'll note it down. The nth term of our AP is given by A1, which is the first term, plus n minus 1 times D. Fine. So let's try to find out let's try to understand this formula with the help of an example. So let's say we will consider our first example. Let's say we have the sequence 9, 12, 15, 18. So what we have to do, we'll have to find out the nth term of the sequence. That means find out an, and we also need to obtain the value of, let's say, the 30th term. So that means we need to find out the value of A30. So first thing first, we will verify whether if this is an arithmetic progression or not. So here, this A9 is our first term. Our second term is A2, which is has a value of 12. Third term, it's A3 with a value of 15, and a fourth term is a value of 18. So here, if we subtract A1 from A2, to A2 minus A1, this is going to be 12 minus 9, gives us a value of 3. If we do A3 minus A2, so this will be 15 minus 12, so this is going to give us a value 3. A4 minus A3, so that's going to give us the value 18 minus 15, which is equals to 3. In each of the 3 cases, we see that we have a common difference of 3, and this is going to be the same for the rest of the term. So hence we can say that the common difference CD, or simply D, this value is equals to 3. So that means now we can represent our nth term. We know that the nth term is given by this particular formula, A1 plus. So here A1 is 9 plus, and we have n because we are trying to find out the nth term. So n minus 1 times the common difference, which is 3. We'll simplify this expression. So we have 9 plus, we'll multiply 3 to n minus 1. So we have 3n minus 3, which simply gives us 3n. So 9 minus 3 will be positive 6. So this is going to be the nth term. Now if we want to find out the 30th term, so that means for n equals to 30, we'll have a 30 which will be given by 3 times 30 plus 6. So 3 times 30 will be 90. So we have 90 plus 6. This was going to give us 96. So this is the 30th term of the given arithmetic sequence. Let's go to the next problem. So we need to show that the following sequence, which is given by log of a, the first term, the second term being log of ab, the third term being log of ab squared, and the fourth term being log of ab cubed, and this continues. We need to show that this particular sequence forms an arithmetic progression, and also we need to obtain the nth term. So let's begin. The first, what we'll do, we'll begin by finding out each of the we're going to simplify each of the terms. So our first term, that's already simplified, it has a value of log of a. Then we come to the second term, which is given as log of ab. Now log of ab can be also expressed as log of a plus log of b. So this is a property of logarithm that we are going to use here. So we have used the fact that whenever we have log of ab, so this is given by log of a plus log of b. Fine. Now let's go to the third term. So our third term a3, that's given by log of ab squared. So we're going to get log of a plus log of b squared. Now we can further simplify log of b squared. Here we're going to use another property of logarithm that states that whenever we have log of a raised to the power of b, this will be equals to b times log of a. Fine. So that means we now have log of a plus 2 times log of b. Right. So this is going to be our third term. Now coming to our fourth term, now if we use these two properties, then we'll get log of a plus 3 times log of b. Right. So we have the first 4 terms. Now what we'll do, we'll try to find out a2 minus a1. So we're going to subtract a1 from the second term. So that means this is going to give us log of b. If we subtract the second term from the third term, that means a3 minus a2, this is also going to give us log of b. And if we subtract the third term from the fourth term, this is also going to give us log of b. Hence we see that there is a common term, there is a common difference for each of the cases. Therefore we can say that our common difference is going to be equals to log of b. This is fixed. And hence we have successfully shown that this particular sequence is forming an arithmetic progression. Now our next task will be to obtain the nth term. So we know that the nth term an is given by the form a1, the first term, plus n minus 1 times the common difference d. Right. So here the first term a1, that's simply log of a plus n minus 1 times the common difference. So the common difference is log of b. That means this will be equals to log of a plus n times log of b minus log of b. We can use these two properties. We'll also use another property, the logarithm of quotient. That means if we have log of a over b, this is equals to log of a minus log of b. So we can use this property to combine log a minus log b. That means we will have log of a over b. Right. We'll keep this aside. And the second term, which is n times log of b, this can be also expressed as log of b raised to the power of n. Now we can combine these two logarithms by using this particular property. This is going to give us log of a times b raised to the power of n divided by b. And if we take the b from the denominator and combine it with the b in the numerator, this is going to give us the nth term, which will be equals to log of a times b raised to the power of n minus 1. So this is the nth term of a given sequence.